Look at this task. 1 bowl and 1 cup have a mass of 700 grams. 2 bowls and 1 cup have a mass of 800 grams. Find the mass of a bowl and the mass of a cup. What mathematical knowledge does this require? This video will discuss MGSE 9 through 12, A, REI 6. Solve systems of linear equations exactly and approximately with graphs, focusing on pairs of linear equations in 2 variables. In 7th grade, students view solving equations as a process of reasoning, which allows them to generalize various methods for solving different types of equations. In 8th grade, systems of equations begin as students graph equations to estimate a solution. An important step is realizing that a solution to a system of equations must be a solution to all of the equations in the system simultaneously. Students begin to solve systems of equations the same way as solving equations in one variable. In high school, students move beyond the focus on graphing to solving systems of linear equations algebraically. Students solve linear systems of equations using multiple methods. Solving systems of equations algebraically scaffolding tasks from the Georgia Department of Education's mathematics frameworks can be used as an activating prior knowledge task to identify possible misconceptions students may have brought with them from 8th grade. Well, remember this line is 2. I'm negative 2.
Oh yeah.
So you want to move it over just a little bit.
So like right here, Mrs.
So this one is 2. This is 1. Negative 2/3 is close to negative 1.
Can I make it closer a little bit?
That's good. All right, so go ahead and draw your line.
Let me see, show me. Oh, right here in the middle, like this.
Yeah, that'll work.
And do you go up here to cross it?
Yep.
Well, you said what you mean? Do we what?
So do you go from the top to cross it, so they can intersect?
Oh yeah.
And so now, what does this point represent?
This one or this one?
Oh, see, I didn't get it a whole another way.
Then do we make a point?
You can, yep. This standard requires students to make an approximated solution for systems of equations through graphing. The Desmos activity, Solutions to Systems of Linear Equations, helps students to understand what it means for a point to be a solution both graphically and algebraically. As students work through this Desmos task, they begin to see that the ordered pair that they created intersects with the line created by the equation y equals x plus 2. Students then begin to think about which ordered pair creates a solution for the 2 different lines. In this portion of the Desmos task, students are asked to think what ordered pair is a solution for both of the linear equations provided. After the scaffolded portion of this task, students are given several graphs in which they have to determine, does the system have a solution? These students are attempting to model this scenario. 1 bowl and 1 cup have a mass of 700 grams. 2 bowls and 1 cup have a mass of 800 grams. Find the mass of a bowl and the mass of a cup. Listen as they make sense of how the linking cubes represent the quantity. So what are your 2 colors going to represent?
This is going to represent the 700 grams.
It's going to represent what?
The 700 grams. The green's going to represent.
What goes together to make the 700 grams?
My party's going to answer.
Okay, but how?
When you look at
He said the 7 cube is going to represent the 700.
right, so but what comes together to make 700 grams in that scenario? What does it say? Yeah, so 1 bowl and 1 cup together make 700 grams. So what are you going to use to represent your cup? The green, okay. And what are you going to use to represent your bowl?
The brown.
All right, so show me what that would look like then. 1 bowl, 1 cup.
1 bowl and 1 cup. How you going to do it?
So where's your 1 bowl?
That's the
This is the
one.
one but we only have 600.
Did you notice that the students interpreted the combination of blocks to be equivalent to 700 and not the quantity of the labels they had attached? It is important to address this misconception in order to help students make the connection from the concrete to the abstract. Listen to how the teacher addresses their thinking. So then that would represent 6 bowls, right? I wanna
Oh,
see
only one bowl.
There you go. Okay, and then where's your 1 cup?
Hey, all right, I get it.
Okay, so now that right there in her hand, what is that worth? 700 grams. Good. So now look at the second part of your scenario. How can you create that, Osiris? What does it say?
2 bowls and 1 cup. Oh, this shit is kind of
That
easy.
makes sense
Hold on.
now?
Yeah, this is
Okay, so now your second bar down there, what is that worth?
That's worth 800.
800 grams. Okay. Students can draw bar models or tape diagrams to model the situation. In this bar model, each combination weight is represented. The bowl is represented with B, and the cup is represented with C. The combination of 1 bowl and 1 cup weighs 700 grams. The combination of 2 bowls and 1 cup weighs 800 grams. We can eliminate the equivalent quantities within the 2 models, leaving us with 1 bowl. 800 minus 700 equals 100. If 1 bowl is 100 and 100 plus C equals 700, the cup weighs 600 grams. What did you do here? Explain to me what you did here.
I canceled this out pretty much.
This.
All right, I lined it up like this,
Okay.
and I crossed these pretty much out.
So physically take away what you crossed out. All right, great. And so what do you have left over?
1 bowl.
I like how you took this part away. Let's think about the weight of each. How much was this? How much did that weigh?
700.
700. And then how much did that weigh?
800.
800. So when we look at your original here, this was how much?
700.
700. And together, this was how much?
800.
So from this 800, how much did you take away?
700.
700. So how much is that?
100.
100. Good. So what is the 1 bowl worth? Or
100.
what does it weigh? 100. So make sure you share that information with your partner, okay? As students transition from the representational phase to abstract, be explicit about the conceptual components and how they occur in the algebraic form of solving systems of equations. In this example, 1r plus 3d is equivalent to 15, and 3r plus 3d is equal to 27. This is represented here in the algebraic expression. Just as with the representational, quantities can be eliminated. It can be concluded that 2 r's is equivalent to 12, making 1 r equal to 6. When substituting this back into the equation, just as with the representational, we can conclude that 1d equals 3. Another important component of this standard is the understanding that not all systems have a solution. While other systems may have infinite solutions or just one solution, some can have no solution. This can be derived from this polygraph activity from Desmos. In the polygraph activity, students work in partner pairs. One partner selects a graph, while the other asks questions based on the characteristics of the graph. These questions should only be answered with yes or no. In this example, one partner asks, "Do your lines intersect?" Based on the answer provided by their partner, they will go through and eliminate the graphs that do not fit the description. This is a great time to emphasize vocabulary terms such as parallel, intersect, solution, increasing, and decreasing.